All right, everybody. What we're going to do right now is we are going to work with, continue on solving equations. We're going to do some one step as a do now, and then we're going to move into two-step equations. So what I want you to try right now is you can pause the video, and I want you to do all four of these problems. All right, make sure you're showing your one property of equality or your inverse step, and then underneath it you would have your final result. So go ahead, you can pause the video, do these. I'm going to go ahead and when you unpause on the next slide, I'll have the full answers. All right, here are the full answers. You can see in white, I have put my one property of equality. So I have, it shown on both sides. So make sure we're doing that, right? This was plus, I'm doing minus on both sides. This was multiplication by -3, so I'm dividing by -3 on both sides. This one on the left, bottom left, was dividing by -3, so I'm going to multiply by -3 on both sides. Again, you should have work that looks just like this. You might not have that 1 on the denominator, that's fine, but you do want to make sure you're writing the times -3 on the left and the right, not underneath. And then here we're going to, right now it was a -25 being combined with that y, so we're going to add add 25 to both sides. So here are your answers that you end up getting. So yeah, that's up there. So that was some practice real quick with your one step. We can delete this. That was not supposed to be there. So that was practice with one step. Well, what we're going to do in this virtual lesson is we're going to work with two-step equations by doing one property of equality at a time to get the variable by itself. Now, the order in which we do this is important. Okay, so there is a process to make sure we're choosing the right one. So we're going to turn to page 14 in your 3A packet, and we're going to learn the two different methods that I have for you to solve when there's multiple steps or multiple numbers on the same side as x. Okay, so in this example, I think it's at the top of 14. It may even be solved for you. Take a look. If not, you can go ahead and write these steps down as well. So the first method is SADMAP. Now SADMAP, if you look at it, is just PEMDAS spelled backwards, okay? Because what we're going to do is we're going to use the order of operations in reverse to undo what is on the side of x, and we're going to get x by itself. So I'm going to go ahead and put little lines here to separate. Okay, subtraction and addition go together, division and multiplication go together, and then we'll split up exponents in parentheses. So what we do is we realize that x it's being multiplied by 3 and 7 is being added to it. Okay, so according to SADMAP, it tells us that we're going to deal with subtraction and addition first. So right here we have a plus 7. We're going to subtract 7 from both sides. Okay, so that's going to be our first step. All right, make sure you're writing it on both sides. And then what we're going to do is, since the positive 7 and negative 7 cancel out, well, the thing that we're going to drag down is going to be 3x. Okay, that's all that's remaining on the left side now. And that is equal to, well, let's see, 19 minus 7 is 12. And we write that down. You must have this line right here. Make sure you bring down that 3x. All right, after that, now after we've done the subtraction addition, we can deal with division multiplication, and in this case we have 3 times x, so we're going to divide by 3, so this would cancel out and become just a 1x. Divide by 3 here, and we have x is equal to 4. Okay, we'll even do a little bit of a check just to make sure this works. I won't bother doing it over here. So here we go. Let's write down our original equation. That was 3x plus 7 equals 19. So what we're going to do is we're going to take that 4 and we're going to plug it in here for x. I'll put it with parentheses. And we want to see if this left side is going to equal 19 when we plug in 4 for x. So 3 times 4 is 12. I'll write this down. Let's see if it equals 19. So 3 times 4 is 12 plus 7. And yes, that does in fact equal 19. So this works out. The answer is 4. Make sure you don't accidentally think that 19 is the answer. That's just showing that our check worked. All right, here's method number 2. It is the party method. You can see our fun little children having a party here. So the party method works like this. What you do is you say, all right, well, x is having a party. Okay, 19 all the way on the other side of the equal sign was not invited to the party. Everybody else here on the same side of the equal sign was invited to the party. Now, x has best friends, the ones who's closest to him, and then other people who were invited to the party, in this case 7. So the party's all over, it's time to clean up, and so your best friend's going to stick around to clean up, which means we have to get rid of the other friend. Okay, they have to go home. So we're going to do that by subtracting 7 from both sides. And then we are left with 3x equals 12. And now it is time, mom, party's over, cleanup's all over, mom said no sleepover, so it is time for our best friend to go home as well. So we're gonna divide by 3, and we end up getting x equals 4. So take note that both these methods are just helping you to tell you the order in which you should be doing your inverse operations or your properties of equality. It doesn't help you with the actual math or anything like that, but again, it talks you about order. So a little bit lower on the page, just I think like halfway down, there's this problem. It's labeled with try this. Okay, so you can pause for a second. I want you to try out either method you'd like, either SADMAP or the party analogy, and I want you to try and solve this. And then once you unpause, I will do it with you. All right, so SADMAP, I'm going to write it down. I'll use this method. So it is saying that we should do our subtraction addition first, and then we'll deal with our division or multiplication. So we have to deal with this negative 12 first. Let's go ahead and add 12 to both sides. We have a negative 5 and positive 12. Well, the positives will win, and by 7. So 7 is equal to, this cancels out, and we're left with r over 4. So take note, once again, I'm dragging everything down that was untouched in the problem. Then here I'm dividing by 4, so I will multiply by 4, and this will cross cancel, multiply by 4, and we are left with r is equal to 28. Okay, and that is our final result. We'll just do a mental check on this one. So 28 over here would be 28 divided by 4 is 7, and then 7 minus 12 does equal negative 5. All right, so that works. All right, let's take a look on 15. So on 15, it's showing 4a plus 3a equals 63. So we have a couple different terms here, which if you refresh back to what we've been doing in chapter 2, it was combining like terms. All right, so or was that 3a? I guess that was 3a. No, it was 2. Anyway, so we have 4a plus 3a. So what you should do on these problems is, if there's some simplifying to do, I know I'm spoiling what the answer is, but look at each side of the equal sign. On the left side, there is some simplifying that we can do. We can combine those. On the right side, we just, is this going to work? There we go. On the right side, all we have is a 63. Okay, there's nothing to do there. So we're going to go ahead and deal with the side that has something to combine or simplify. And I'm going to combine 4a plus 3a, which does get us to 7a. And now this should look just like a nice one-step equation. We will divide by 7, and we end up with a is equal to 9. All right. Now, the one thing I do want to do, I do want to complete a check for this one, since it's our first one that we're dealing with that have multiple of a single variable. So I'm going to go ahead and rewrite this. And in my place of my couple variables, I am going to go ahead and plug in my 9. So we'll add in plus 3, and once again I'm putting an empty parenthesis for the a value, and I'll plug in the value that we think that a is, which is 9. So we're plugging into both spaces. So 4 times 9 is 36, plus 3 times 9 is 27, equals 63. We'll add these together. 6 and 7 is 3, and then put a 1 up here. 2 plus 3 is 5, plus the 1 is 6, so 63 does equal 63. So I just wanted to show you how to do it if we have multiple variables to plug in for. All right, if you want to go ahead and pause here on 15, there are 3 other problems. We have 5x plus 4x equals 36. I'm not going to read them all for you, but I want you to complete these problems. So that's number 1, 3, and 5. All right, I'm going to go ahead and just start solving them. I'm not going to do a check next to them. You can go ahead and do that if you'd like, but I'm going to go ahead and just solve them, and you're going to go ahead and graph it. All right, I'm going to solve it. You can go ahead and check your answer against it. So here we go. If you want to rewrite this, you can. I'll actually do it. Put my right side on my left side just so they're switched. And I get my x on my left side of the equation. Some people like that better, but then everything works the same. And there you go. So feel free to pause at any of these steps. So if you want to, just look at the different work that's shown. But there you go. All right. The last thing we're going to do is we're going to take a look at a couple problems on page 19. So let's turn there now. Our video is getting a little bit long here, so I'm going to go ahead and try to speed run these next couple. So if you have double signs, you need to change them before you move on. So here we have x plus a negative 4 equals 8. We're rewriting this. X minus 4 equals 8. Think a positive times a negative equals a negative, right? So here we go. Here's your problem that you're going to work on. So we can add 4, and we get x equals 12. I'm not going to do a check for this one, but what I will say is this. So we're going to show the check on the next one. You do not need to go back to the double signs for your check. No, go here, right? You do not need to go back to the double signs. Just work from here when you do your check. Let's do this one. Okay, again, let's rewrite it. X plus 4 equals 12. Remember, once again, double negative can just turn to a positive. And now from here, to undo the plus 4, we're subtracting 4. Okay, so x is equal to 8. Once again, just go right here for your check. So we just plug in an 8. 8 plus 4 equals 12. Okay, that works. All right, let's keep it moving. So look at number 3. Okay, number 3, okay, this one's a little bit different and kind of is going to relate back to what we were just doing with these 2 steps. So this is a little bit weird, but there are 2 steps here. So I have a 6 that I want to get rid of. Okay, it's a positive 6. Well, the way to undo or invert that 6 is to subtract 6. Now, it is very important that when you drag this down, unlike these other problems where we just drag down a positive x, this is a negative x. Okay, you can think of this as having a 1 in front of it. So this is a negative 1x. We do have to drag that whole thing down. So it's negative x is equal to 6. I'm going to put that negative 1 in front. This is not isolated the way we want it to yet. We want a positive x. So the way we need to get rid of this negative 1 is just like if we had a 3 here. If this was 3x, we would be dividing by 3. Well, instead of dividing by 3, we have a negative 1. So we'll divide by negative 1. And all this is going to do is it's going to switch our sign. So x is equal to negative 6. So notice here, a second ago, we were just at negative x, or it could look like this. Negative x equals 6. Well, notice how all the answer does is change both signs switch. So instead of being negative x equals 6, it's x equals negative 6. All right, so keep that in mind. If we were to check for this one, let's take a look at what it would look like. So it says 6 minus x equals 12. Well, I'm plugging in a negative number. So watch what I'm going to do. I'm going to do 6 minus and put my parentheses, so that's where my x is going to go. And I'm going to replace it with the negative 6. So for a moment, I have double signs. Well, that's 6 plus 6 because it's double negative, and that equals 12. This is true, and we're good to go. All right, I got 2 more for you. All right, so looking at this one. So it's kind of similar with that negative x. We will make sure we drag down that negative x. But here, people see this and they get a little bit concerned, right? Let's just pretend for a second. I like to pretend, and feel free to write it out. If there's fractions in your problem, to try and figure out what inverse step you're going to need to use or property of equality, let's just write this without fractions. It does not even matter the numbers you write in. We're just trying to figure out what operation we need to do. We have 3 minus x. Well, to cancel out this 3 that's here, we need to subtract 3. Okay, and that would leave us with negative x equals, so again, we know what we're going to do. We're going to do subtraction. So I'm coming over here, and I'm going to do minus 3 fifths. Minus 3 fifths. Okay, so that's going to leave us with nothing here. We'll have negative x is equal to, well, we need to do some fraction work, right? So let me erase this, and I'm going to bring my fraction work over to the side. I have 1 over 2 minus 3 over 5. So I'm subtracting with fractions. I need common denominators. So I'm multiplying this by 5 and 5, multiplying this by 2 and 2 to make a common denominator of 10. So that's going to be 5 tenths minus 6 tenths. Okay, I know my denominator is going to be tenths. Now I'm going to do 5 minus 6, and that gets us negative 1. So my result here is negative 1 over 10. Now, once again, this was a negative x that we dragged down. So we need to switch our signs. Okay, you could divide by negative 1, or again, you can just think the signs need to switch. So this is going to turn from x, and this is going to turn to 1/10 positive. Okay, so I'll write it bigger right here. X equals 1/10. All right. right? Or if you're just getting a little long, I'm not going to do a check here, but you just plug 1/10 in right here. You'd probably want to make common denominators to, see if this does equal to 1/2. All right, last problem I have for you. Okay, last problem I have here. I like to think of this one with the party analogy, but first I'm going to explain how SADMAP does work because people get a little confused on these ones. By the way, this is on page 20. So they say, well, okay, SADMAP says we should use subtraction and addition first, okay? Which would mean we should probably do something with this -8. But we can't do that. It's here at the, it doesn't really work because it's inside, it's at the top of this fraction. So here's the thing. When we have an expression inside of fractions, there are implied parentheses here, right? Implied meaning that they're there, but not really shown, okay? They're known, but not shown. So we, according to SADMAP, PEMDAS, or parentheses come last. So we're gonna deal with that last, which means we have to worry about this dividing by 3. We're gonna multiply by 3, okay? And remember, this is 3/1, so these will just cancel out. That's the whole reason we're gonna do it. We'll multiply by 3 over here. So this whole n plus 8 is going to drag down because it was untouched, and it's equal to 18. And then we can go ahead and subtract 8 because it's the only thing left. So now we can do that subtraction we were looking to do earlier. So we get n is equal to 10. All right, and that's our end result. I'm going to explain it one more time really quick just with the party analogy. I kind of like to think of it on this one. So we have 2 different friends that were invited to the party. We have +8 and 3. 8 is the best friend because it is the closest to n. It is on the same side of the fraction as n. So we're going to get rid of that 3 first. It's dividing by 3. We're going to multiply by 3. And then from there, we're back to where we started, n plus 8. Now the best friend can go home, and we're going to -8 from both sides. I'm not going to write it again. So there you go. So problems I would recommend you try are as follows. Page 19, number 4 and 10. Page 20, number 13. If you have more time, maybe you can do a couple more on that page. But yeah, there you go. So that is how we are dealing with multi-step or 2-step equations. And that is by doing one property of equality at a time by using SADMAP or the party method. All right, bye.